So again, ladies and gentlemen, welcome back. We're going to now talk about completing the square by changing a standard form quadratic into vertex form of a quadratic. And I'm taking example 3 from your package where it says review of quadratic functions, all types. Just got to give you a moment to take a look at that. The equation is y equals 2x squared plus 5x minus 1. And again, for the question it says complete the square. So for those that are in the class, you might want to just look first before you start copying things down and ask me things as we go through. The first thing we tend to do, we take what's called a partial factoring of the a across the first two terms. Now notice I did not do a total real factoring, I did a partial factoring. So if you were to expand this, 2 times x squared is 2x squared, 2 times 5 halves is 5x. I think everyone understands what I'm doing. Again, I recommend, ladies and gentlemen, you might just want to watch first before you copy it down, just so you can follow along. I now notice this is not a nice number, right? That's why I'm trying to share with you, ladies and gentlemen, in grade 11, they're not always nice. But this is now our new b. We take that 5 halves, and what do? We divide it by 2. Now notice where I'm doing this off to the side, because this tends to be easier. So when we divide by 2, what does it really mean? Multiply by the reciprocal. So really this answer is, when you divide by 2, is 5 over 4. Everyone agree? And then what do you do with that 5 over 4? Our third step is we square it. When you square this 5/4, it becomes 25 over 16. Now why am I doing this? I'll explain it a little bit later. But this mechanism, dividing the new b by 2, always divide by 2, and then square that answer, is related to the perfect square quadratic. Now we'll talk more about that as we get there. The whole point I'm trying to show you is what some teachers actually skip, but I am definitely specific. Notice I left a gap. Everything I copied is exactly the same. And what we're going to do is add by 0, but not just any 0, a specific 0. What 0? I'm going to write plus 25 over 16 minus 25 over 16. Let's just take a look. Everything's aligned the same. Everything. The 2, the bracket, the x squared, the plus sign, the 5 half x. This bracket is here. This minus 1 is up here. So I think a lot of you understand this is 0. Some teachers in grade 10 skip this step. I don't know why they do. Because the whole point of why this is called completing the square, what I'm underlining, this yellow line, x squared plus 5 half x plus 25 over 16, that trinomial, that's a perfect square. It's not a nice perfect square, but it's a perfect square nonetheless. And so you're supposed to complete it. What does that really mean? Factor that trinomial. So you say, okay, Mr. Jen, I understand that you're supposed to factor. But I find it difficult to factor this weird, I think that's 16, a weird question. So what am I going to write? Well, ladies and gentlemen, you actually already did some of the math. If you take a look at your step 2, you've already done it. 5 over 4, you put that right over there. And this is the answer. Now, we're not finished yet, but x plus 5 over 4 all squared is the factored form of the perfect square of this x squared plus 5 half x plus 25 over 16. Here's where a lot of students actually make their mistake, though. They do all this amazing stuff, and then they forget to use distributive property to clear those brackets, those square brackets that I introduced when we factor. Now it's scary because some students say, well, do I put the 2 in this x? The answer is no. You're just getting rid of these square brackets. When you get rid of the square bracket, you get 2 times this x plus 5 over 4 squared. 2 times this negative 25 is negative 50 over 16 minus 1. And this is why you need to know how to add and subtract fractions. Negative 1 is the same thing as negative 16 over negative 16 over 16, right? So 50 minus, now we technically should have reduced this, right? Maybe we should have reduced this. So 50 over, which is 25 over 8, I think. So let's make our lives a bit easier. 8 over 8. Is that okay? Did everyone see what I just did? That was 50 over 16, right? Because it was 2 times this, and then I just reduced that fraction. This is a little easier. So what's 25 minus 8? I think that is 33. And this is the vertex form.